All right, we're back, and in this we're going to be coding SatisfactionScale, which is using logical operators along with our if statements that we learned in the last video. So let's get started with what in the world is this thing. We're going to write a program called SatisfactionScale that asks the user to input a number, an integer, in the range 1 to 10, right? 1 inclusive, 10 inclusive. So 1 is a possibility, 10 is a possibility. Then, based on the user's input, we're going to kind of respond. Right? If the user gives us just a straight 10, they couldn't be more satisfied. An 8, 9, we would say that they're quite satisfied. Anything in the range 5 to 7, we would say that they're moderately satisfied. 2 to 4, so on and so forth. Okay? Let's get started. I'm in IntelliJ. I'm going to make a new project by going to File, New, Project. Our JDK is already selected, so we'll go next. We'll go next. I'm in my principles folder, so we're ready to just type our name, which is going to be SatisfactionScale. Notice IntelliJ creates the subfolder for me as we type. That's awesome. We'll hit finish. I'm going to expand my project folder, right-click on the SRC, and make a new Java class called SatisfactionScale. Let's go ahead and plug in our main method with PSVM. Okay, and I want to implement scanner because we need to get input from the user. As I showed you the last time that we coded max of 2, max of 3, that you can just skip to straight to step 2 where we create our scanner object. So I'm going to create scanner, and as I'm typing, the IntelliSense and IntelliJ is figuring out what I may mean, and I want this first option. I'm going to hit enter. And it takes care of step 1 for me. It imports our scanner. I have a scanner variable called input, and it's going to be a new scanner that reads from system.in. Step 3. We're going to prompt the user. We'll say something like, on a scale from 1 to 10, how satisfied are you? That's going to be an integer, so I'm going to create an integer. Let's call it sat, and that is going to be coming from input.nextInt. Okay, so all I've done is implement scanner. We're getting an integer from the user, in theory, in the range 1 to 10. 1 to 10. Okay, let's start processing this. All right, looking back at our slides, if they give us just a straight 10, we're going to say, couldn't be more satisfied. Well, this is easy. Let's knock that one out first. If sat is exactly a 10, then we can say, couldn't be more satisfied. As we learned in our last video, if the body of an if statement only has one statement, we can omit the braces, meaning I technically don't need these bad boys. Okay, why don't I actually go ahead and test out what I got so far. I'm going to right click in free space and tell it to run. First thing that's going to happen is it's going to say, on a scale of 1 to 10, how satisfied are you? And it's going to kind of wait for the user to enter a number. If I do exactly 10, we get the response of couldn't be more satisfied. If I were to run this again and do any other number, like a 7, nothing is printed. And that makes sense, right? The user entered 7, they get saved into my variable. We're going to ask, is 7 equal to 10? Well, no. So we skip over this body, and there's nothing else going on, so that's the end of it. Let's look at our next category, right? It's when we got 8, 9. Now, you could do basically a similar format where you ask, is sat equal to 8? And you do a separate if statement where you ask, is sat equal to 9? But that's basically duplicate code because the statement quite satisfied would be in 2 separate places. In our last video, we learned about logical operators. So we can actually test for both of those in one if statement. I can say if sat is exactly an 8, or sat is exactly a 9. right? This is the OR logical operator. And in this case, it kind of makes sense. If we have an 8 or 9, we're going to enter the body of this if statement, at which point we would say, quite satisfied. Okay, let's take a look at our next category. In this case, we got 5, 6, 7. What most students tend to do is they'll do something like if sat is equal to a 5, or sat is equal to a 6, or sat is equal to a 7, which works, right? I haven't even really taught you this yet. I mean, I guess kinda. We got logical operators going in here, but we haven't really combined them other than looking at just those logic gates. In the event that we got a 5, a 6, or 7, we're going to print off moderately satisfied. Okay, so something of note is how this expression ends up getting written, right? This works. We're combining these relational operators. Something of note is that with these logical operators, each side has to be a Boolean value. And I'm actually getting Boolean values, right? The Boolean value is being produced by this relational operator. I'm getting a Boolean value from this expression. I'm getting a Boolean value from this expression. So we're going to have something like true or false, determining what the actual outcome of this is. Similar thing down here. The way this one is going to end up working is that we're going to get a Boolean value here. We'll get a Boolean value here. This will produce a Boolean value, meaning the whole expression that I have highlighted is one Boolean value, which constitutes the left side of this logical operator. The right-hand side over here, I'm getting a Boolean value from this relational operator. So that's what's happening there to ultimately give us our statement. Now, one thing I will kind of talk about or say here is this works. There's only 3 possible outcomes in this category, right? 5, 6, or 7. But imagine if there's more. What if you got 100 of these in this category range, right? What if this scale is actually 1 to 100? And the user could enter a number like 66. And it has to appear in a range of 50 to 79 or something like that, right? This isn't really going to work. So I want you to think about other ways that this could work. What I really want is a number range. Right? What I really want is 5 to 7 as it's expressed in our slide, where 5 is a possibility, 7 is a possibility, but also everything in between. Okay? So let's think about that. How would you go about doing that? In mathematics, we would do that number range by saying 5 is less than or equal to sat, which is less than or equal to 7, right? To see, is this number in this number range? Well, let's try plugging just really that in. If 5 is less than or equal to sat, which is less than or equal to 7. I didn't really like this. Let's take a look. It says the less than or equal to cannot be applied to Boolean int. What's going on here? Well, I'm getting a Boolean value here from this left-hand side. We're saying 5 is less than or equal to sat, true or false. That's going to produce a Boolean value. So what I end up having then is true or false is less than or equal to 7, and that doesn't work. So as it turns out, we can express number ranges. We just need to use our logical operators. In order to represent the number range in Java, we're going to take a logical operator. In mathematics, it'd be expressed like this, as we just typed out in our code and saw we didn't work. But we can say, is 5 less than or equal to sat, and is sat less than or equal to 7? These two things are functionally equivalent. And what we end up having here is a Boolean value on the left-hand side. We can get a Boolean value on the right-hand side, and then the AND logical operator is going to produce another Boolean value. So let's bring that in. We'll say, is sat less than or equal to 5, is 5 less than or equal to sat, and is sat less than or equal to 7? Let's try this out and make sure it works. Right, I'm going to run my program. And on the a scale of 1 to 10, how satisfied are you? I'm going to go with a 5. And that triggered our moderately satisfied. That looks pretty good. Let's try some different numbers. Let's try a 7. Still moderately satisfied. That works. I'm going to try something else, like an 8 or a 9, to make sure we're not doing something crazy. That triggered the quite satisfied, but not the moderately satisfied. Okay, what happened here? Well, 8 comes in from user input. We're going to ask, is 8 equal to 10? No, so we would skip this if statement. We would ask, is 8 equal to 8? That's true. We would ask, is 8 equal to 9? That's false. I have true or false. Overall, this produces a true value. So we enter the body of the if statement, and we're going to print off quite satisfied. We then have, is 5 less than or equal to 8? That's true. Is 8 less than or equal to 7? That's false. So I end up with a true and false. Overall, this produces a false. So we skip over this body, and that is why we don't see moderately satisfied. Note that we did check the condition. It just wasn't true, right? 5 less than or equal to 8? That's true. Is 8 less than or equal to 7? That's false. True and false gives me a false value. So that's ultimately how that ends up working. We're representing a number range. Something of note is that, like, you could express this kind of differently. The fact that it's broken up like this means that you could write it something like sat is greater than or equal to 5 and sat is less than or equal to 7. That is the exact same thing as what I just had. Okay, so you do have some options there. I just invite you to kind of go with what you think is most logical. To me, this is trying to show that sat is in a number range 5 to 7. Okay, so with that in mind, let's jump back to our scale because we got 2 to 4. Well, it's going to be pretty much the same thing. We would say if 2 is less than or equal to sat and sat is less than or equal to 4, well, that's going to be, what, moderately unsatisfied? Well, sorry to hear you're not satisfied. Sat is fide. Okay, let's test it out, make sure. I'm going to do a 2, that's the low end of my range. I'm going to do a 4, that's the high end. If we do something else, like an 8, right, it triggers something completely different, and we actually don't enter this body because we say, is 2 less than or equal to 8? Well, it is. Is 8 less than or equal to 4? No. Giving me a false value overall. Last little bit on our scale, just a simple 1. If we get a 1, we couldn't be more unsatisfied. Couldn't be more unsatisfied. If sat is exactly a 1, couldn't be more unsatisfied. And we'll use an emoticon because we're super hip. All right, let's test that out. If I do exactly a 1, rip, didn't have number lock on. Exactly a 1 is going to be, couldn't be more unsatisfied. We'll ask, is 1 equal to 10? No. Is 1 equal to an 8? No. Is 1 equal to a 9? No. Is 5 less than or equal to a 1? No. Is 2 less than or equal to a 1? No. Okay, so we end up skipping everything else. We test it, but we end up skipping everything else and ultimately choosing this option. Now, something most of you are probably recognizing is, how satisfied are you? I'm an 11. Okay, so what I would like to do is a concept I call validating user input. We want a number in the range 1 to 10, but Scanner, I mean, this thing is going to accept whatever the user is typing in here. Note that if they type in text, there's nothing we can do about that. Right? We're looking for an integer. The user gives me a hello world. I can't do anything with that. But if they give me a number that's out of range, my program still technically works. I'm just not processing their input. Now, you could maybe do just a simple error message, right? Maybe we have an else here. indicating it's something else. It's not in the range 1 to 10. Please enter a number in the range 1, 10. Right, this is one way to handle it, and probably pretty decent. But what I like to do is validate user input. That is, the moment that we get their input, we check it to see what it is, making sure that it's in this range. Now, we can actually use an if statement to do that. And I want you to kind of pick out, what is the moment that we have user input? What line number? Okay, line number 9 is the moment that I have user input. So the moment that I capture their input, I want to validate it. I want to make sure that it's in the number range 1 to 10 before I continue on with my program. Right? That's going to end up saving us time later on. Like, why go through the entire program when the input is just wrong anyway? So what I want to do is include an if statement to check to see it is in the range. SAT is in the range 1 to 10. Let's invert that logic, because really what I want to do is, in the event that it's not in the range 1 to 10, I want to basically give them a chance to enter a new value. So why don't we finish out the body here? So if SAT is not in the range 1 to 10, we're going to basically print off an error message, and then we're going to give them a chance to enter a new value. Now, in the future, we're going to be able to do this with loops, which means we'll indefinitely be able to validate the input, meaning there's no way that they can give us bad input. However, right now, all we really know is if statements. So what this if statement is going to allow them to do is give them one more chance, effectively. In the event that they give me something that's not in the range 1 to 10, I want to print off an error message. Right? I want to say, please enter a value in the range 1 to 10. So I'm going to print off the error message. I'm then going to give them another chance. What do I mean? I want to capture an input, right? I want to recapture a new value for SAT. Right now, if I enter this if statement, SAT is not a good number. It's 16, 15. Okay, so let's capture input again, right? It's effectively this line again. In fact, why don't we just go ahead and copy and paste both these things? Notice IntelliJ is mad at me here. I know it's mad at me up here. We haven't entered a condition, but it's definitely mad at me down here. What's going on here? It says variable SAT is already defined in the scope. All right, a couple of videos ago we talked about scope. SAT gets declared up here. It continues to exist into the body of this if statement. That's what's going on here. I don't want to redeclare SAT. I just want to reassign it. Simple fix. I'm going to get rid of this data type. I don't want to recreate the variable, right? On the left-hand side, we have variable declaration. I don't need to redeclare it. I just need to give it a new value. In the event the user gives me a value that's not in the range 1 to 10, I'm going to ask for a new one. We'll use scanner in order to capture the new one, save it in here. Okay, then we continue on with our program. Notice that I'm reusing SAT. So in the event they give me something that's not in that range, hopefully they'll give me something that is, and then my program continues on. Okay, so the question now is, give me a condition that says that SAT is not in the range, right? We got the range 1 to 10. Give me the other stuff. Well, SAT is not in this range if SAT is less than 1 or SAT is greater than 10. Notice we're using an OR logical operator here. I want you to think about this for a moment. Right? The moment I put AND in here, IntelliJ highlights this with yellow, saying this is always false. Think about this. No number is less than 1 and greater than 10. Right? My inclusive range, we used AND. What I want is the exclusive range. If SAT is less than 1 or SAT is greater than 10, then it's not in this range. Let's try this out. See what happens. On a scale of 1 to 10, how satisfied are you? I am a 12. It says, please enter a value in the range 1 to 10. On a scale of 1 to 10, how satisfied are you? Notice that my program is still running. It's waiting. It's here, waiting for me to enter a new value. Okay, how about just a 10? We'll tone it down a little bit. Couldn't be more satisfied. Okay, so what happens is we give them another opportunity. Now, I know what a lot of you are thinking is, if I come in here and I'm a 12, then it says that's wrong. Okay, how satisfied are you? I'm a 12. And that's what I was talking about with the loop situation. In the future, we'll be able to basically use a loop, which will do this indefinitely. But as of right now, we at least give the user one more opportunity to nail the number range. The last thing I want to show you is a different way to maybe express this. What do I mean? Well, we saw the not logical operator. We haven't really used it a good bit. But think about this. I'm saying if SAT is not in the number range 1 to 10. Okay, what does the number range 1 to 10 look like? We did number ranges down here, right? This is the number range 5 to 7. This is the number range 2 to 4. What is the number range 1 to 10? Right, we would say 1 is less than or equal to SAT, and SAT is less than or equal to 10. That is the number range 1 to 10. I want this if statement to trigger if it is not this. That's as easy as taking this expression, and I'm going to negate the whole thing. If SAT is not in this number range. So that is one way to kind of express this. Let's try this out and see that it is actually the exact same thing. I'm going to do an 18. Okay, that triggered my if statement. I know because we see these SOPs here. It's waiting for me to enter another one. I'm going to do a 10. Couldn't be more satisfied. Okay, so this is what the slides from the previous video were saying, is that the not logical operator could sometimes be used to make more elegant expressions. Now, there's a lot more stuff going on here, right? Maybe this isn't exactly elegant to you, but in terms of like English, the way I read this is if SAT is not in this number range, which is what this comment is kind of saying. So different ways to kind of express it. Choose the one that you like the most. That's going to wrap it up for Satisfaction Scale. I hope you couldn't be more satisfied. See you in the next one.